Hi everybody and welcome to another Bowtie Teacher video. In today's video I'm going to be looking at my predictions for the June 2020 Paper 3H from Edexcel GCSE Math. I've analysed every single question from all of the new specification papers and put together a database which allows me to track and trend all of the different data sets to try to ensure that I give you the most accurate predictions for what I think is going to come up in the exam. So without further ado, let's get started. So as you can see from this diagram, I have all of the topics arranged in order so that the size of the box represents the number of overall marks available for each topic. And it goes from the top left down to the bottom right. So as you're studying, you should try to ensure that you cover all of the topics available, but you can focus your energy a little bit more because now you know that the ratios, for example, is the most important topic to study. And as you go down and to the left, you can see interpreting data and basic probability, and you just work your way down and across, making sure that you cover as many of these as possible. In my last video, I talked about quite a lot of these already because there's so much of an overlap between paper 2 and paper 3. It's not as split up as the IGCSE, for example. So take a look at that video and just make sure that you cover all of the things like basic probability, rounding and ratios. And in this video, I'm going to focus specifically on the things that I haven't mentioned before and give you an overview of those and how we would answer those questions in the exam, together with some calculated tips and tricks to help you to make sure that you've got all of the correct answers. Okay, so we'll start with interpreting data and let's take a look at what that entails. Okay, so in the Edexcel GCSE there are many different ways that you can interpret data. I've got some examples here that I can show you where you have a box plot and it's asking you to describe the data and maybe the differences and the similarities between them. So when you're doing this type of question, look at the extremes of the data, i.e. the maximum and the minimum and the range. Talk about the range and where they're different. You can also talk about the interquartile range. So this is the lower quartile and this is the upper quartile. And you can talk about the spread of the data by using the interquartile range as well. And then you can look at the median here and the median here and try to relate it to the context of the question. So if they're asking you about wait times in a doctor's surgery or something like that, then try to link it back to that initial context. What we also have when we're interpreting data is we might have something like a cumulative frequency diagram, and then they ask you to talk about, 25 or more minutes waiting, and you can try and interpret it like that, or they might ask you for the median or interquartile range or anything like that. They're asking you to use the information that you have. Sometimes you have a scatter graph like this, and you can put your line of best fit, and they're talking about outliers, so they might have one over here, and they might ask you to try to predict something just like in science like that. You've also got examples where you have a speed, distance, time graph, in this case a VT graph, and it goes something like that. And then they ask you to work out the distance traveled. So you would do this kind of thing where you split the graph into strips and work out the area of the trapezia there. And you'll see that because the area of the trapezium is slightly bigger than the area under the curve, that this would be an overestimate. So they ask you to estimate this and to talk about this in terms of overestimates and underestimates. So there's many different ways that you can interpret data from Edexcel. These are just a few of the different ways. Make sure that you understand what's going on with these and that you can try to get the context involved as much as possible. The next topic is angles in a polygon. This includes triangles, but mostly this is to do with when you have a polygon and they give you a couple of the sides and they say, right, so the interior angle or the exterior angle is such and such, and they want you to work out the number of sides. So the formulas that we're interested in is the exterior angle is equal to 360 divided by the number of sides, which is n, and then we have the interior angle, which is number of sides minus 2 times by 180. So we can use a combination of these to work out any question that involves angles in a polygon. And we also have this amended one when we have a regular polygon, we can divide that by n to work out an individual interior angle. So that's when it's a regular polygon. So let's say we are told that the exterior angle of this is 20 degrees and we want to know how many sides we have. So we would do exterior angle is equal to 360 over n, but we're given the exterior angle, so we're going to rearrange this to get n equals 360 over the exterior angle, which in this case is 20. So this would be an 18-sided shape. Sometimes they'll give you the interior angle. For example, if this was 140 degrees, and they said, how big is this, how many sides does this have? It's better to just work out the exterior angle and do the exact same process, okay? But you can use the interior angle one if you want. It's a little bit more complicated, but we have an interior angle here is 140, and that equals the number of sides minus 2 times 180 over n. So we can multiply this out, and we get 180n minus 360. And then we can rearrange this to get 360 equals 40n. So you can see we're doing the same calculation as we would do using the exterior angle. We're actually just working out the exterior angle with this formula anyway. Okay, so angles in a polygon will always be based around these two formulas. So make sure you know those off the top of your head, and you can rearrange those to find out the number of sides or the interior angles. Sometimes it will be an irregular shape. Let's say it's a hexagon, and they're giving you lots of these, and they might have x and 2x, and these are all values that they're given. Then you would use the interior angle sum formula, which is the first one without the divide by n, and then you would just subtract these and work out from that equation that you're left over with. The next topic is quadratic simultaneous equations. So let's just review what that actually involves. You have a quadratic equation like this, and a linear equation that might look like something like that, and we're trying to find out the intersection points of the two graphs. So that's why we get a pair of x and y coordinates for the first intersection, and then another pair of x and y for the second. Sometimes this equation might be a circle, but we deal with these in exactly the same way. So how do we do that? Well, we rearrange the linear equation to find x or y, and then we substitute that into this quadratic equation. So in this case, I'm going to substitute for x. So I will do 3x equals 7 minus 4y, and then divide both sides by 3 to get my x value. Once I have that, I can now substitute that into x squared. So I've got 7 minus 4y over 3 squared minus 4y squared, and I'm going to minus 9 equals 0, so that I can start to form a quadratic equation with y. 7 minus 4y squared, I'll do that as a double bracket like this. So on the numerator, I'm going to have 49 minus 28y, and another 28y is 56y, plus 16y squared. And that's going to be all over 3 squared like that. And I'm going to subtract these that I still have left over. I'm going to times everything by 9 to get rid of this denominator, so that 9 will go, and this will become 36 and 81. So I have 16y squared minus 36y squared is negative 20y squared. I've got minus 56y, and I have 49 minus 81, which equals negative 32. I'm then going to rearrange this to make this a positive y squared, so I'm just going to put a plus in front of all of these, and divide by 4 to get 5y squared plus 14y plus 8 equals 0. So when I put that into my calculator for my quadratic here, I got 5, 14 and 8, and I got negative 4/5 and negative 2 as my two values. So I can have y plus 2 and then 5y plus 4 as my brackets. Y equals negative 2 and y equals minus 4/5. So when I have those two y values, I can now substitute into my original to get my x here. So x is equal to 7 minus 4y over 3. So x equals 7 minus 4 lots of negative 2 all over 3. And x equals 7 minus 4 lots of negative 4/5 over 3. So that's 7 plus 8 over 3 is 5, and 7 plus 16/5 over 3. 7 plus 16/5 divided by 3 17/5. So my final values are x equals 5, y equals -2. That's my first intersection. And then I have x equals 17/5 and y equals -4/5. So this is how we would go about quadratic simultaneous equations. We find a linear term and we substitute that into the quadratic, solve for x or y, and then substitute back into the linear to find my other coordinates. The next topic that I want to talk to you about is sine and cosine rules, and when to use which one and how you go about it. So with sine rule, what you're looking at is a triangle with two sides and two angles. Okay, so two sides and two angles, and then one of those will be unknown. So you might have one side and two angles, or you might have one angle and two sides like that. With the cosine rule, we're looking at three sides and one angle, with one of those being unknown. So your job at the first part of this question is to identify which of these rules you're going to use, and you just use this guide to help you. So three sides and one angle is going to be cosine rule. Both of these formulas are at the front of the book, so just make sure that you look at the front, get the correct version, and then substitute in to find out your values for the sides or the lengths. Now what's most likely to happen is that you're going to use a combination of these in a question where you've got, say, two triangles like this, and they give you various angles and sides. Okay, so they might give you something like this, 4.7, 6.3, and they want you to find out, say, the side that's in common. You usually find the one that's in common like that, and then you can answer the question by carrying on from there. So it might ask you to find out this side here if you know another side like that. Okay, so when you're doing these types of questions, just try to break down the question into which one it is first, sine or cosine rule, and then try and work from there. Whenever you're doing these kind of trick questions, try to look at the side that's in common to both, and that will allow you to break the question down, and that's the link between the two. So iterations is quite a complex topic because it's pulled straight from the A level, and what you have to be able to do with iterations is rearrange these complicated quadratics and cubics to get it equal to 0, so that you can prove that there's a solution between, say, 1 and 2. Okay, because what will happen is if you substitute 1 into this, it will give you either a positive or a negative, and then you put 2 in and it will be the opposite sign. So you observe a sign change between these two values. So we just rearrange this: x cubed plus x minus 7 equals 0, and let's call that f of x. Then you would do f of 1 and you do f of 2, and you would see a sign change here. So let's do 1 cubed plus 1 minus 7. So 1 plus 1 minus 7 is -5. And then we put 2 in here and we get 2 cubed, which is 8, plus 2 is 10, minus 7 gives you 3. So you can see a sign change here. And what that would look like on the graph, if I just zoom in onto this graph, at this point here, x cubed plus x equals 7, between 1 and 2, the graph would be going from -5 up to +3. So you can see that there's just passing through the x-axis between that range there. So because it's going through that range here, you know that there's a solution because the sign has changed from a negative to a positive. The second part of this question would be something like rearrange this to get x equals the cube root of 7 minus x. Okay, so when you're doing this type of question, just try to look at the equation and see if you can make it look like the one that they want. It's like a show that question. So we're just going to rearrange the original equation, so we get x cubed equals 7 minus x, and then we're going to take the cube root of both of these to get the cube root of 7 minus x like that. Okay, you might have an alternative like something like x equals 7 over x squared plus 1. So in that case, we would take x bracket x squared plus 1 equals 7. So we'd factor the x out, and we could do x equals 7 over x squared plus 1 like that. So these different rearrangements that you can possibly have give you the different solutions that you would need for this graph. So if it crossed over at different times, at different places, then your different rearrangements would give you those different answers like that. So we're not really interested in this one here. Let's focus on that one there. We can use an iteration to start off this equation. So if we start off with xo equals 2, and we start substituting this into here, what we would do is we would get our xn plus 1 equals the cube root of 7 minus xn. And all that means is that you're starting with your first value of 2, you put that into the equation and you get an answer. And then you put your answer into this equation and you get the next answer, and it iterates. That means it goes through a kind of loop. So if we have our calculator here, and I like to put our first value, our xo, in as the answer by pressing 2 and then equals. So now I can do the cube root of 7 minus answer, because that's going to be the value that we've just calculated. So we can find out the second answer like this, and we can keep iterating. And as you keep doing that, you'll see that eventually you'll converge into a root of this equation. Okay, so let's just do that again. We put 2 and then equals, and then we're going to do the cube root of 7 minus answer. Okay, so it will take the answer each time and put it back into the equation. So it says it wants it in this question 3 times. So the first one, xo equals 2, x1 would be 1.709, so x1 equals 1.7099. Then we press it again, 742, x2 equals 1.7424, and then the next one is 7388, so 1.7388, like that. Okay, so let's just use our calculator to check this. We can go to the solve polynomial degree 3, and I'm going to rearrange this equation. So it's x cubed plus 0x squared plus x minus 7 equals 0, and we'll substitute those values in. So 1, 0, 1 and negative 7, like that. And you can see 1.739 is one of our solutions, and there's another 2 there. So 1.739 is what that solution would converge to if I kept iterating through as best as I could. The final topic we're going to talk about is sequences. So we have 2 types. The first type is when the sequence is going to go up by the same amount each time, and that's called an arithmetic progression or arithmetic series. So these ones are relatively easy to deal with because you look at the difference between each term like this, and in this case it's a 3, so that becomes our 3n. And if we put the 3 times table up here like that, then to get from the 3 times table to our original sequence, we just subtract 2 each time. So if you look at 12 minus 2 or 9 minus 7, that gives you your answer. Okay, so with the arithmetic series, we just have to work out what the difference is between each term, and then we use a plus or minus a certain number to get back to our original sequence. With our quadratic ones, sometimes called geometric progressions, these ones are going up by a different amount each time. So we might have something like this where it goes up 3, 5, then 9 and 15, something like that. So in this case, when we look at the difference, we have a difference of 2, then 4, then 6, and the difference between the difference is 2. So how we deal with this then is that we've got an extra added layer of complexity with this, because the difference of the difference is 2, whereas this one, it's just the difference. It's the second layer we're looking at. So this difference of the difference here, we divide that by 2 every single time, and that will become our n squared term. Okay, so 2 divided by 2, that's going to be the 1n squared here. So I'm going to do n squared, here's n, 1, 2, 3 and 4, so our n squared is going to be 1, 4, 9 and 16. So now that I have my n squared sequence here, I'm going to find out how much the original minus the n squared gives us. So this one minus this one gives me 2, 1, 0, negative 1, like that. And I'm now going to work out the nth term of this sequence here, and that will give me my remaining part from my quadratic sequence. So 2, 1, 0, negative 1, that's going down by minus 1n. And then when I have my minus 1n, I have to add 3 to that to get to this number here. So this sequence is going to be n squared minus n plus 3. So hopefully from my original document you can see the topics that you need to really focus your studies on. I'll put a link to this document in the description below, and if you have any questions then please leave them in the comments. Otherwise, I wish you all the best of luck in your exams in June.